Hello folks, and welcome to today's Expert Talks Online. My name's Lindsay Brewer. I'm a delivery lead with Equal Experts, and I'll be the host for today's session. Whilst waiting for people to join, I'll just be chatting with Dave about what drew his attention to the Cyberpunk 2077 release. So Dave, there's a lot of IT projects out there that are newsworthy. I just wondered what drew your attention to this particular one?
It was just the newsworthiness, really. I'm going to talk a little bit about my YouTube channel, but I was looking. The cyberpunk problems were in the news, and so I started looking at those just from kind of academic interest a little bit, and started to see some things that I thought, to me at least, seemed like reasons why things might have gone badly.
Mm-hmm.
And so I thought that might make a good video. So then I started digging a bit more and looked into what information was available about the way they worked and so on. But it was largely just the prominence in the news, and you know, I was playing the game of thinking that might be something that would appeal to people on my YouTube channel, as well as everything else.
Yeah, and judging by the amount of interest in that particular video, you were right.
So way more than we expected. But I think it's interesting. So part of the stuff that interests me, and one of the reasons why I do the YouTube channel really, is to talk about different ideas in software development and software engineering. In a way that's not specific. I'm not trying to say press this button now and do this thing. I'm talking about the ideas and the concepts more. And so looking at real world examples and trying to take, learning from real world examples seems like a good way into thinking about how we can practically apply some of the ideas that we talk about in more technical, more processy terms in software development.
Yeah, that definitely makes it more tangible for people to get a handle on if they're hearing about something that's actually happened and difficulties in a particular situation, how they were overcome or could be overcome.
Yeah,
it's always easier for people then to transfer that to their own context.
I think so. So as we're going to talk a little bit this evening in this evening's presentation, I had some lovely feedback on the Cyberpunk video from people saying, "Oh, I've never thought about it this way," or "Oh, that makes sense, and that makes me think about these other things," which is exactly what the kind of thing that I would hope for, of course.
Great. Okay, right. Let's kick off properly now. We've got 44 people online. So again, welcome to today's Expert Talks Online. My name's Lindsay Brewer. I'm a delivery lead at Equal Experts. I'm going to be the host for this session. We're really, really pleased and grateful to have Dave Farley with us again today. Dave is a thought leader in the world of software engineering, plus the author of many books, including the award-winning book Continuous Delivery. He previously spoke at Expert Talks Online on that very topic. So if you'd like to hear more of what Dave has to say about continuous delivery, you can see a recording of that talk, which was part of a continuous delivery series. You can find those talks on the Equal Experts website. In today's talk, Dave's going to be reflecting on the failures of software engineering as exemplified in the Cyberpunk 2077 release. Cyberpunk 2077 is a first-person shooter game that has been 8 years in the making, and it was finally released in December last year. So we're going to have the talk, and then Dave's going to cover any questions. So if you have questions come up in the talk, please add them using the Zoom Q&A widget that you should be able to find. Please vote up questions that you'd most like to see answered, and we'll go through them in order of most votes. Great. Okay, so let's hand over to Dave. So over to you, Dave.
Thank you. Hello, everybody. So I'm just going to share my screen, and hopefully you can see it now. So, I'm going. This is a slightly different kind of talk for me. This is going to be a little bit more autobiographical, I suppose, than my talks usually are. I usually talk about software development, software engineering, technical ideas, and don't really talk about me specifically, other than to kind of pull out some of my experiences. But I started something when the pandemic started, really, but it was something that I had in mind for a long time. I began a YouTube channel roughly this time last year, and it was going very well. So my YouTube channel is called Continuous Delivery, and it is we were doing pretty well. So my son and I, who helps me with some of the marketing around the YouTube channel and so on, we were taking bets at the end of last year whether we'd be able to hit 2,500 subscribers by the end of the year. The week before Christmas, we released a video which was about Cyberpunk and the problems that the Cyberpunk 2077 release were very publicly having. And this kind of succeeded to an extent that was probably beyond our wildest dreams. I'm not, some of this will sound a little bit like I'm bragging about this thing, and that's not my intent. I just want to talk about this because one of the things that was really fascinating was that as a result of the popularity of this video, which was in a very different league to most of my videos, I got thousands of comments against this video, and there's some really interesting stuff in there, which is one of the things that I want to talk about this evening. So I created this video, and as you can see from this is a copy of the thumbnail. Those are the little pictures that we use in YouTube to try and draw people's attention. Part of the game of YouTube is to try and get your stuff in front of enough people so that that they're going to click on it and watch your video. There are literally millions of new videos per day being added to the YouTube platform. And so there's this ridiculously high level of competition to try and get any video in front of its viewers. So playing the game a little bit in YouTube is part of the game. So this picture, the title is a little bit clickbaity, and we chose the Cyberpunk video because we thought that's something that might pull a few extra viewers in. And what we thought at the time we were probably hitting, we were doing well if we could get 1,000 views in a week. We were doing very well if we did a video that did 1,000 views in a week. Mostly we were probably about 500 views per week for the first week of a video launch at this point in the channel. So we launched this video, and we did rather better than that. So in the first 2 weeks, we got to 407,000 views. You can kind of see the numbers on here, which are ridiculous. The number of people that saw the thumbnail, the picture that I just showed, was nearly 4 million people saw this. We've got way more views than this now, and it's still growing. So why did we do this? Well, clearly the Cyberpunk software release was a very newsworthy thing, and my channel is about software engineering, and so I thought it would be interesting to look at what lessons we could take from this very public problematic launch, and if we could imagine ways in which applying the kind of ideas and the kind of things that I generally talk about, they could have done better. They could have not had quite such a disastrous problem. So first, let me just, in case you haven't been seeing any of this, this is the slightly less clickbaity title that was the real title of the video: Bad Software Engineering Killed Cyberpunk 2077. My videos, I should say, are not sensational. They are about software engineering and development ideas. But sometimes we use the techniques to try and get people to click on them, because that's part of the YouTube game. That's just part of playing the game. So there were big problems. There was an interesting video that showed a whole bunch of snippets of the failures of the Cyberpunk launch, and primarily this launch was about running on the older consoles. It seemed to be doing the game seemed to be doing quite well if you ran it on a PC with a big graphics card, but and it did quite well on the very newest game consoles. But the market is in these two things. This is where nearly all game sales are, to a large degree, still currently on the PS4 and the Xbox One. And as a result of the failures of the being able to run on these more hardware constrained devices, the share price of the CD Projekt Red, which are the company that made the game, kind of plummeted through the release of this software. So this is a big deal for them, and they're in the news again today because they've been held to ransom, and so they're not in a happy place. I would feel a little bit more sorry for them if they weren't kind of taking some advantage of the people that work for them, which we'll talk a little bit about later. The source for the information that I used to try and figure out what was going on in this game, largely I didn't want to go down a sensationalist route and look at all people's kind of emotional comments and all that kind of stuff about games. So mostly I went to the CD Projekt Red website and read through what they were saying about their game and their development approach and so on. And then just looking at publicly available sources that weren't kind of overly sensational. So in my video, I showed an example of some job, recruiting adverts that said things about how there's 7 different kinds of great coffee, but they didn't say anything about automated testing, for example. And there's a variety of ideas that we could kind of infer. So I don't have any insider knowledge. It's quite possible that some of my my suppositions are wrong, but I came to some fairly basic conclusions, and I think there's not much to argue with those conclusions. So the first one was this, really. So how do you go about planning a big project of any kind? And if you at all been involved in that kind of thing, this will be sort of familiar to you. The levers that you have available to, this is sometimes called the iron triangle. You have scope, schedule, and resources. The proper name for resources in this sense is people. And this is long time, old school project management thinking. These are the levers that you have to control the rate at which you can produce software. There's one more lever that some organizations sometimes pull, and this is a lever that CD Projekt Red pulled. They decided to reduce quality in order to try and hit the schedule. Now, this is a very big game. This game has been planned for years. It's been in development for 8 years, and they started off saying that they were going to wait until the game was ready and good before they released it. And at some point, they clearly got nervous because it had been going on for 8 years and they weren't there yet. So they started cutting corners on quality. I don't know at which point they did that. They also so quality is a terrible lever. It really is not going to allow you to hit your schedule any quicker. It may work for a week. If you're really, really lucky, it might work for 2. But longer than that, if you try and improve the rate at which you produce software by reducing the quality of what you produce, you are very, very quickly going to be going slower, because your development team will be fighting the horrible code base and the low quality and fixing defects instead of creating new features. So quality is a crap lever to use to try and address this kind of problem. Resources is rubbish as well. We kind of know from the data that small teams are really important. There's a famous quote which I did use and I'll refer to later, from Fred Brooks in the Mythical Man Month in 1970, and he said, "You can't make a baby in a month with 9 women." There's a limit to how parallel you can go with certain kinds of processes. So you don't get to go faster just by throwing people at a problem. Too many organizations try to do that, but it always ends up badly. There's some lovely data about the effectiveness and efficiency of small teams. There's some research. There's a metadata analysis of the productivity of teams. They divided the cohorts, more than 4,000 teams. They divided them up into teams of 5 or fewer and teams of 20 or more. And they found, and then they measured how long it took them to get to 100,000 lines of code. The teams of 20 people or more beat the teams of 5 or fewer they came out ahead. On average, across all of the teams, it took 9 months. The teams of 20 people or more, on average, took 1 week shorter time than the teams of 5. So a team of 5 people is almost, but not quite, 4 times as efficient as a team of 20 people. And we've kind of known that kind of thing for a long time. Software doesn't scale up by just throwing people at it. So we're left really with only 2 levers, scope and schedule. And I think, I'm going to start talking in terms of time rather than schedule, because I think that's more accurate what we're talking about. We're talking about how long is it going to take before we're ready to release something, and what is it that we're going to release? Those are the real levers that we can use to have a concrete effect on our projects. And so let's think a little bit about scope and how we might, let's think about these two, how we might do this. What too many organizations do, what I think in the end CD Projekt Red did, was they fixed scope and time. We got to have the whole game, it's got to run everywhere, it's got to be perfect, and it's got to be out by this time. And it wasn't ready, so they launched too soon. It was a disaster. The quality of the software suffered. And that was a big problem. This really doesn't work. This, and we're going to get into the reasons why. But this really doesn't work at all. There are other strategies. So we could start thinking about dealing with these things independently of one another. And one of the companies that is famous for doing this, if you think about it, is Apple. Apple are famous for almost never pre-announcing their products. There have been very few occasions where they have pre-announced something, but on the whole, they don't. And mostly all we know about what's coming from Apple are leaked secrets. So what Apple are doing is essentially they're fixing the scope. They decide internally what they consider insanely great will be for their product, whatever that means. And then they will carry on working on it until it's ready, at which point they'll release it. Inevitably, they're going to have plans internally and so on, but they don't publicize what's going to be in the product, or when the product's going to be available, or any of those things. So they have the option, they have the freedom to manipulate time, decide on when they're ready, and go then. The other alternative is that you fix time. You say we're going to hit the deadline. We're definitely going to release at some point at this point in the future. So we're not going to be very accurate about what's going to be included in that release. We're going to give ourselves freedom of movement on the scope of what's included in our release. And we manipulate that. Let's look at that in a bit more detail and start thinking about the way that plans work. So what's a perfect plan look like? So in order to create a perfect plan, we need to understand our goal. We'd need to know all of the steps necessary to achieve that goal. We need to know how long each step is going to take. And we'd also need to be able to know all of the interruptions, mistakes, missteps that get in the way on our way to achieving that goal. So let's try and think about that. So we're going to start off by understanding our goal. This is what it is that we're going to achieve. And now we're going to understand all of the steps that are necessary perfectly, what those things are going to be. And then we're going to figure out exactly how long it's going to take each of those steps to achieve each of those steps. And through some kind of prescience, we're going to know all of the interruptions that happen along the way. There's a problem here. A perfect plan like this is a perfectly stupid idea. We can't make those predictions. We're not going to be able to accurately predict in detail how long each of those steps are going to take. We're not even going to know what all the steps are, and we certainly aren't going to be able to predict all of the things that could hit us along the way. Global pandemic, anybody? You know, these things are not plannable. And so working, assuming that we're going to work to a perfect plan is a dumb idea. And I think that this is the trap that CD Projekt Red eventually fell into. They fixed the time, they fixed the scope, and they didn't hit it. So what's the alternative? What could we do instead of that? Well, we can start off assuming that stuff can go wrong, because it can, and it might. If it doesn't, nice, but it probably will at some level. So let's imagine that we did want to work to a time. So here's our time, our expected date, and we're not going to commit to the scope. We're not going to remember that's how we said we were going to deal with a fixed date. We're going to vary the scope, and we'll work as quickly and as efficiently as we can. We'll make sure that every single feature that we create is always releasable at every point. Done means ready to go into production with no more work. There's no more additional inspection. There's no integration test. There's no manual sign off. There's none of that stuff. We work so that each individual feature, each individual change is releasable. And that way, whatever the date, we can release what we've got up to that point. Now, whether this collection of features makes a coherent release or not, we don't necessarily know, but we can make the decision because this collection of features will be functionally complete, production ready. We can then carry on making more features after the initial release, if we like, upgrading it, updating it, enhancing it, and so on. Or we could move the release date around. We've got the option. So we are moving the target that we're trying to hit from being a precise point fixed in terms of time and scope to being a variable point. That's, you know, we can move the axes so we have greater control. Another way of thinking about this is kind of the kind of classic waterfall planning model, which is kind of something like this. We've got time along the bottom and features up the side. So we're going to build up a set of features. Then we're going to do a business case first, and then we're going to do some analysis of what it's going to take to be able to do that. Then we're going to design something, and then we'll develop it, and then we'll test it, and then we'll release it. And what usually happens at this point, halfway through, sorry, I got ahead of myself. Halfway through a project like this, what you've usually got is nothing. You've got nothing tangible, nothing to release, nothing of value other than ideas. You've got some theoretical ideas that might be good or might not be at this point. So the way that these tend to play out, the way that this kind of plan tends to go wrong is a bit like this. You start looking into the business case and it's a bit more complex than you think. So, you know, you've got plenty of time. It's ages before the release date. So you do a bit more work, and then you start digging into the analysis, and the people doing the analysis think, oh, those designers are crazy. So we better do a thorough job. We'll do a detailed job there, and then the design takes a bit longer, and then that means the development starts, and the developers don't like the design, but they're trying to work around it. Testing nearly always tends to get squeezed because they don't shout loudly enough, and you go into production and there's a big problem. What usually happens in response to that is that a project like this goes into something variously, usually called something like emergency change control. And emergency change control, we kind of do a bit of each of these things. We do a bit of the business case, we get sort of triaging, which we're going to work on, the analysis, the design and the development and the testing, and we do all of those things, and that's how we kind of progress until we've got high enough quality in production. I think that this is, I call this the illusion of rigor. It gives us a nice, warm, cozy feeling that we're being thorough by doing all of this work up front. In reality, we're not doing a great, efficient job. And I think this is kind of what part of the problem with CD Projekt Red was. A more agile plan looks more like this. One nice way of explaining this is that you go into emergency change control from day one. So you do all of the same things, you just do them over a shorter time scale, over a more limited scope to more limited outcome. And you create a releasable outcome at the end of each of these little blocks. The way that these sorts of projects usually go wrong is different. So first is halfway through a project like this, what you have, if you've prioritized half your work sensibly, you've got the most important half of the features ready to release because they're production ready. At the end of each one of these little blocks, it's production ready. The way that these sorts of projects tend to go in reality is it's a bit more variable than that, and they do tend to accelerate over time. And so for people used to the first style of planning, they usually scare the hell out of people because agile projects tend to start off quite slowly, looking at lots of problems. That's a good thing because what you're doing is that you're learning and you're surfacing a lot of the problems that in a more traditional plan would bite you later. The other thing that's interesting is at the point at which I stop this, we tend to go faster and faster and faster, and then we'll hit a hiccup of some kind, and we'll go slower for a bit, and then we'll carry on going faster again. So the plans look really different, but the key idea here, the idea that I was trying to get across, is that we have something releasable much, much, much earlier in the life of the project, essentially from day one and throughout the life of the project. There's one more version of graphs that I want to look at. So if we're thinking about predicting the future, which any kind of plan is really about, then we should start being a little bit more thorough, a little bit more mathematical. If we think about the features on the vertical axis and time against time on the horizontal, then the reality of our project is going to be some kind of vaguely random walk. And so now, if we want to predict where we're going to end up, we can kind of project, we can extrapolate these points. These are the best case and the worst case lines based on our historical real delivery so far, taking into account all of those random interruptions that happened to us so far, our problems with the technology or the problem, me fighting with the tech lead on the other team or whatever else it might be. You know, this is the reality. This measures reality. So we can kind of track this. We can move these things. The green and red lines are probably going to vary over time. Well, inevitably will vary somewhat over time. You know, if we get something, suddenly we go faster, our optimistic one will go up. If we suddenly find a problem, our pessimistic one will go down and so on. But we can use that and keep tracking that and projecting forwards. This tells us something interesting. So now, if we're interested in a fixed time plan, we can say, okay, this is the range of scope that we expect to be available at that time, based on our best case performance and our worst case actual performance. And similarly, if we fix scope, we can say, okay, this is the earliest time when we could possibly release that scope on the green intersection, and the probable latest time based on our current data. So again, what I'm trying to point out to you is that we've kind of moved away from having a single precise point, a single coordinate based on scope and time, and got into a range of values which we're more likely to be able to hit. And so this is a more sane plan. This is a picture of a deployment pipeline. This is a picture that if you've ever seen me talk in public, I've probably shown you before, because I use this picture a lot. This represents to me how a deployment pipeline works and the way that continuous delivery works to some degree. And I think that continuous delivery is not what many people think it is. One of the key ideas for a deployment pipeline to me is that it goes from commit, creates a release candidate, which we then evaluate with all sorts of automated tests and so on, and it goes to a releasable outcome. And we do that, we optimize to get that feedback multiple times per day. And this was really at the heart of the message that I was trying to convey in my video about the failure of the Cyberpunk project. This is about engineering. All of this stuff that I'm talking about is about engineering. It's about engineering a solution. What are the techniques and the technologies and the approaches that we can use to engineer some kind of outcome? And if the development team had started off always from day one working with this kind of mechanism, with these kinds of ideas, then they would have been constraining themselves to work so that every single change that they made was finished to the degree that it was releasable. Now, that doesn't mean that they're going to release it or that it makes sense to release it, but it's written, created to a quality where they, as far as they know, there is no more work to do before that change is ready to go into production. And that's the heart of continuous delivery. So overall, what I've kind of described to you is kind of the arc of the story that I told in the video, and the denouement, the point that I was really trying to make, which was work so your software is always releasable, and then it doesn't matter. You know, the decision to release then is down to, you know, when you've got enough stuff to work to people. And one of the things that I said in the video, you could imagine if they decided, if they were working when they started working 8 years ago, for sure, then the latest version of the PlayStation and the Xbox weren't around. So if they'd started doing their testing and their performance testing from day one, and that was part of the releasability of the system on the hardware was available then, they would have known that they had a problem and they would have fixed it as they went along. So it would have been ready to release for the lowest spec hardware. So you could imagine them saying, you know, we're going to release on this. And if it wasn't, we're going to release on PS4 and Xbox One. We'll do enhancements to make it even better on PS5 and whatever, forgotten what the new Xbox is called. Later on, or vice versa. If it really didn't work on those things, they'd know it because they had the tests, and they could decide we'll make it available on PS4 and lower spec hardware later. You've got those choices, but working to a completeness is really the engineering discipline that offers those choices. So what did this do to my YouTube channel? It kind of moved me into a different game, really. As I said at the outset, last Christmas, we were around about 2,500 subscribers. We were regularly hitting, we were doing well. We were well above average for a YouTube channel. But this video so far, it was released Christmas week. This video so far has had 455,000 views and is still growing a few thousand views per week. My channel has gone from, has gained an additional 19,000 subscribers. So I'm kind of 21,000 subscribers now. And that's growing at about 100-ish per day. And I'm starting to get an awful lot of different attention, different interest on the channel and so on. But as I said at the outset, one of the fascinating things was really starting to go through those thousands and thousands of comments on the video, as Dave Gorman calls it, the bottom of the internet. The first thing that I noticed was that quite a few people enjoyed the Fred Brooks quote about making a baby in a month with 9 women. This last one was kind of funny. You can't make a baby in a month with 9 women, but I want to try. So there's a few comments like that, and there were some funny things. There were some quite unpleasant. There were a very, very tiny proportion of quite unpleasant things that were posted as well, and I tended to edit those. I didn't edit things that were critical of me or my channel, but I did try and edit out any racism or sexism from, you know, blatant stuff from the comments. And then I had the lovely experience of people enjoying my stuff, which is why I've gained so many subscribers, and people said all sorts of nice things. I find it particularly pleasing when I get somebody that's starting out in their career and said it's given them some new insight into what's going on. So I gained lots of subscribers through this. But inevitably, there was a whole bunch of other stuff, which is probably the more interesting stuff for us to talk about in terms of what does it mean in terms of software engineering. And this is starting to go on the transition now. So we haven't quite got to the more critical things, but the first one of these is that this is managers thinking. This is the nasty management that are you know, beating on the developers, and it's hard to argue with that for CD Projekt Red, really, because one of their reactions was that they do what they call in the games industry, they crunched, but they did that for 18 months. Crunch means working 10 and 12 hours a day, 6 days a week for 18 months. These people were really under the gun to try and get this video out. And if you've ever been involved in a project like that, then you will know that that is not the way to speed up either. I once worked on a project where we were working 80-hour weeks. My boss had a double first from Oxford. He was a genuinely brilliant man. And he got to the stage where if you asked him if he would like tea or coffee, he couldn't answer the question. He was a decision-free zone because he was so burnt out by the rate at which we were working. So this is no way to become more productive, but it's what happens in the game industry quite a lot. There was this comment at the end, which was, I didn't know Jeremy Clarkson knew quite so much about software engineering, to which I think the cheeky bugger, but there you go. And there was lots of people that were just kind of misinterpreting what I was talking about, saying, I really liked the game, why are you critiquing it? And I wasn't critiquing the game. Everybody else was critiquing the game. I was critiquing the software engineering. But I'm not here to make excuses. So the next sort of set of comments that are interesting. I've already mentioned this. Please don't put all the blame on software engineering. It could be that the game was not ready and the leadership pushed it into production. Well, yeah, they did. But that's kind of what I mean by engineering. I have in front of me a cup. This is an engineered artifact. It's not engineering. Engineering is the process by which we got to this cup. The software engineering is the process by which we develop software. And so the planning and the execution of that plan are the engineering. It's absolutely, the code isn't the engineering. And that was a really, really, really common theme in all of this kind of set of comments. These were talking about it, talking about this from a management perspective is misleading, talking about this being engineering and so on and so on. It had nothing to do with software engineering. It was about project management. I don't know what they think that software engineering means. I think that if I was to sum this up, this is really a question of what does engineering mean? And I think that's an important point. So this is a point that matters a great deal to me. So I am currently in the throes of writing a book trying to define what I think software engineering means. And so I have some thoughts on this, and which is why I did the video in the first place. And one of the things that I think is important is that engineering is about the application of scientific rationalism to solving practical problems within economic constraints. It's about the way in which we go about solving problems. It's not about the solution. It's not the solution itself. A bridge isn't engineering. It was created through engineering, but it's not engineering in its own right, really. And so thinking about the mechanisms that we apply to software development, I think that software engineering, certainly in some communities in software development, has got a bad name, and rightly so, because I think it tried to be overly prescriptive and too narrow. I think that we should be thinking in terms of optimizing for learning and optimizing for managing complexity and those sorts of things. And so this is really what engineering is about. It's about thinking about the ways in which things can go wrong and trying to cure them, which is what my example of the plan was about. How can a plan go wrong? Well, it can go wrong by trying to fix time and scope, because that's unrealistic. So which one do you want to morph? It's trying to react to reality rather than just apply magical thinking. And so that, for me, is deeply what engineering is about. The next set of comments was really, who on earth is this guy to point the finger at game development? What games has he ever worked on? And that's a fair criticism, I suppose. In fact, it's not dreadfully relevant, I don't think, personally, but I have actually built some games in the past. So I know what's involved in writing games. I started off in my career, doing quite visual programming, doing a lot with computer graphics. And these were in the days when you started off writing a game by writing an assembler function that would draw a line on a screen and so on. So it's a long time ago and very, very different, I am sure, from a modern AAA game. But I think that this rings bells for me. I work as a consultant, and until the pandemic started, at least, I was traveling globally to organizations all around the world, advising them on adopting the kind of stuff that I've been talking about to improve their software engineering. And one of the most common comments that I get, whatever the nature of the organization that I'm dealing with, is, oh yes, but we're a special case. You know, these are all really good ideas, and I'm sure they work fine in this example over there, but they won't work for us. And I'm just hearing the same here. This is just saying gaming is special, a special secret little cabal of different things, and you don't understand it. And I'm afraid I just don't buy that. My experience is that there are no special cases. If we were genuinely to come up with ideas that were engineering for software, I think they'd be pretty generic. I think they'd be pretty fundamental. I think they'd be kind of unsurprising, because we probably know them already. We just don't apply them often enough or regularly enough. But they'd be pretty fundamental, pretty foundational to the way that we worked, and so pretty broadly applicable. And I think that's what we see. So if we start thinking about the kind of hyper agile approach to software development that is continuous delivery and its related practices, I think most people most commonly probably think of organizations like Google, Netflix, Amazon, who were some of the early adopters. And they did that for good reason. They adopted this stuff because nothing else scaled well enough for them to be able to make progress. They were kind of constrained by more, I'm trying to think of a more polite word to say than old-fashioned, but I can't. More old-fashioned way of developing software. So they started innovating with software approach and so on. And so they were some of the early adopters and well known. So does it work for regulated industries? Well, yeah, sure. That's where I spent most of my time. Examples from LMAX, the exchange that I was involved in creating, one of the highest performance financial exchanges in the world. Siemens Healthcare. Build devices that work in hospitals. Citibank, heavily regulated in the finance industry. ING Bank, Government Digital Services, GDS, regulated from a governmental point of view. So yeah, it certainly works in regulated industries, although every regulated industry that I go to says it couldn't work here. Does it work with hardware, embedded devices and FPGAs? Yeah, I've done it with both of those things. Some in finance, others in scientific devices. Yeah, definitely works for those. What about C++ or COBOL or legacy systems? Those are going to make it difficult. They change the game. They change it somewhat in terms of the way in which you approach certain aspects of solving the problem, but they don't rule it out. You can definitely do continuous delivery with C++. I know of a company that do COBOL on a mainframe doing continuous delivery and do acceptance testing. And they say it's really easy to do the acceptance testing because they can do everything through a dumb terminal, and they can kind of fake the terminal emulation as an input to the system. What about machines that can kill you? Well, sure, Siemens healthcare machines can kill you if it goes wrong. But a better example, perhaps, because that's probably not how they'd prefer to advertise it, is the US Air Force. They are using continuous delivery to deploy changes into fighter jets. What about grown-up engineering? Can't possibly work there. Well, Volvo Trucks went from it taking 6 months to get a single line change into a truck on a test track to it taking 20 minutes using the techniques of continuous delivery. Tesla famously you buy a Tesla car and your car gets better and better and better on every release. And they publish a fair amount of detail of their fairly sophisticated continuous delivery engineering process to producing and releasing software, including the self-driving AI systems that are coming. Ericsson are currently rolling out the entire global 5G network that they're responsible for using continuous delivery, and are also publishing about it. SpaceX write the software for their spaceships using these techniques. What about AAA games, though? Well, yeah, there was a great talk at the Pipeline conference a couple of years ago from one of the tech leads from the Sea of Thieves development team, who did continuous delivery for a AAA game from the start, and he said the whole team was blown away by the effectiveness and efficiency of the approach. So there aren't really any special cases that I can think of that I've come across where this kind of thinking doesn't apply. Engineering really means the stuff that works, and if it doesn't work, we change it so that we find stuff that does work. That's really what engineering thinking is about. Software engineering should increase our chances of success. It's not about some kind of artificial brownie points that we gather because we're smarter than everybody else because we draw cleverer pictures of the software or anything. It's, do we create better software faster? And if we don't, it's not software engineering. So the stuff that I'm talking about is about that. It's about how do we work so that we increase our chances of success of creating better software faster. And when we apply these techniques, it works. Thank you very much. That's my talk. Not bad timing. I wasn't quite sure how long that was going to take, so I'll stop sharing my screen.
Great, Dave. Thank you very much. That's perfect timing. That's allowed us just under 10 minutes for questions.
Right.
Now, we currently have 4 questions that we'll work through in order of votes. If you have further questions that you haven't added yet, then please feel free to put them in using the Q&A panel. So the first question is, you stated near the beginning that adding people to a software delivery doesn't always reduce the time to deliver. Are there any patterns such as organizational or architectural delivery patterns that can allow more people to more effectively collaborate on a single delivery?
I was going to say yes until the last phrase. So the collaborate on a single delivery is the problem. The way in which you scale up is pretty well understood. And the way that you scale up is basically you distribute the problem. So you create many small independent autonomous teams who can do work independently. And the example that everybody uses for this for very good reasons is Amazon. So Amazon, interestingly, can, if they double in size, they more than double in productivity. Which is really, really deeply unusual. But if you look at their output, if you go and look at AWS in particular, and look at the smorgasbord of services that they produce, I think they published 1,800 changes last year to the AWS fleet of services. And there's overlap, and there's no consistency in the different UIs or admin experiences for those services. That's what you give up if you want these things. If you want to scale up by throwing more people at problem, you give up the coordination. There are some fairly serious hard limits on how far you can go at adding people to a problem, because the communication overhead and the coupling of all of the pieces starts to cost. There are ways of working that allow you to grow, but you have to grow very cautiously to not trip over this problem. And there's data on this kind of stuff from many years. This is one of the things that Fred Brooks was writing about in his book, which was published in 1970. The idea that you can't scale up by just adding people to a problem. So it's a difficult problem. Software is this complex stuff, and the way to scale up is to compartmentalize it. And then there are a variety of techniques. Microservices is one, but microservices is significantly more complicated than most people think it is, because microservices by definition says that you don't get to test them together. If you are building independent services and testing them all together, it's not microservices. It might be good, but it's not microservices. It's something else. Microservices is the most scalable architecture, but it comes at the cost of needing these things to be independent from one another, meaning that you don't get to test them with each other, so that you retain the ability to deploy them independently, and that the teams working on them can make progress without being constrained by other people's work or
excellent.
Right.
Thanks, Dave. Okay, we'll move on to the next question from Richard Webb. Do you think the issues you've been talking about aren't as common in the normal software cycle? It's just that they're not so kind of well publicized?
I think that they are completely endemic in the normal software development. I would say that the issues that I've talked about are, I don't have the statistics to back this up, but my subjective impression from my sample set of clients and the code bases that I see these days is that this is still the norm for most organizations. Most organizations are still working like this. Most organizations are not working so that their software is always in a releasable state. When you do, that's kind of light and shade. It's a paradigm shifting change in the way in which we organize and plan our work. But it's not how most, there are many organizations that do. There's all of the examples that I gave at the end, Tesla, Google, Ericsson, all those sorts of places are doing this kind of stuff, and more all of the time. And often the ones that we think of as kind of the examples of excellence are doing this kind of stuff, and this is why they're excellent.
Great. Okay, thanks, Dave. Next question is from Paul Dambra. Could you share the reference to the study you mentioned about the team of 20 who finished a task 1 week earlier than a team of 5? Maybe you gave them some statistics from a study just after you're talking about Fred Brooks.
I can. Let me. I can see if I can find it now. But also, sorry.
Yeah, or perhaps if you can dig it up later and then kind of post it on your YouTube channel, that'd be great.
Yeah, I can definitely do that. I do have a video that's that describes that, and I'm trying to remember which one it is, but I can't remember now. That doesn't matter.
Thank you. Right then, next question by Silva. So in a project with the scale of Cyberpunk 2077, do you think it's possible to correctly define the scope and the schedule of the various stages of the project, considering that if they were using continuous delivery, they would have had a quality usable product at the end of each stage, and at the same time modular enough to be complemented with future iterations? So I think they could have broken up Cyberpunk into kind of stages, use continuously approach to get those done and grown the software in that way.
So I am 100% convinced that they could do that. Could they retrofit that to where they are now? be really, really probably impossible given the complexity of their code base and so on. I would assume, but you know, take the software, all the software that's in a Tesla car. That is vastly more software and vastly more complex software than in even a very complex video game like the Cyberpunk game. It has no fewer challenges in terms of the points at which it touches the world and interacts with the real world. That's the hard part of testing something like a game, is the fact that you've got such a big surface area in the graphics of the game to manipulate the content of the code. But that's about you. What happens when you buy into these ideas is that you start to code stuff so that it's testable, so that it's deployable. And that is one of these engineering things that amplifies the quality of your design, so that if you're going for testability and deployability, what you get as a side effect from that is more modular code, better cohesive code, code with better separation of concerns, code that's more loosely coupled, and code with better seams of abstraction in it, because that's what testable code looks like. And all of those things are also happen to be the hallmarks of high quality in code. So this is, you know, engineering amplifies our ability to get a better outcome. I am 100% certain that if they had adopted this from day one, they would have created code, their system more efficiently, and it would have been a better code base at the point at which they released it. Now, does that mean that their idea was good or whatever? I've no clue about that. It might still be, it might be a bad idea. I don't know about that. That's not what I'm talking about. I'm talking about the engineering process of producing the software.
Okay, great. And then following on from that, kind of related to engineering kind of approach, Kevin Duffield was wondering about whether tooling plays a part. He's wondering if is it fair to say that kind of outside of gaming, there's in more generic fields of software, we're spoiled by the support given to us by the tools that we have that support iterative practices. He's kind of wondering that if game studios are having to build a lot of their tools from scratch, then it makes it harder for those tools to support the kind of practices that you have been talking about.
I don't think that's a constraint for gaming. No, some of the tools that we have are nice in other fields for sure. I'm not rubbishing the tools, but I was one of the. Forgive me sounding like I'm boasting, I'm not, but I was one of the pioneers of continuous delivery, which meant that there weren't any tools, which meant that, you know, that we built all our own tools. And take it from me, who has built these tools, it's not that hard. They're not that difficult to build. You can build simple. Some of the tools are lovely and sophisticated and clever and so on, but the value that you get out of this approach to working is available to you with tools that you can build in a day or two. That's all it takes. And then you can make them a bit more sophisticated over time as you grow your software in complexity and so on. So I don't think you need, you know, perfect tooling or any of that sort of stuff. And I don't think even if you have those things, it necessarily gives you the ability to do this stuff. It's much more about the way in which you think and approach your work and the way in which you apply these ideas than it is about the tools themselves, because the tools are relatively simple. You need something that's going to organize your build for you and run some tests for you and give you some feedback on it. And then you're going to need some stuff that's going to deploy your application in a repeatable, reliable way. And that probably means that you need to control the environment a bit. So you need to version control that. So you need the version control system. You need something, you know, you can build this sort of stuff even on top of relatively simple build management systems like Jenkins or something, with no problem at all.
Okay, great, thank you. So the next question from Thomas is I think based on your talk, is the software gaming industry really advanced, which means it's hard to apply these techniques, or is it kind of really backwards, which means it's finding it hard to apply these techniques?
I think the latter. I said in kind of my intro that I'd written some games many years ago. One of the things that I think is really nice about writing things like games compared to other kinds of software is that you are more you are less constrained. You know, your objective is to do something fantastic, visually, you know, impressive, break new barriers, you know, all that kind of stuff, which is lovely. It's nice to be able to have that kind of freedom. You're not constrained by, you know, the formal layout rules for a screen or something like that. You got a lot of freedom, so that's a good thing. So I think in some ways game development is more advanced in that sense. I think in terms of the approach and the procedures that they apply, I think that they are a very long way behind most commercial software development these days, based on the kinds of stuff that we've been talking about today, the ways in which we organize our work and so on, you know, and the idea of just crunching down and making people work harder for longer. It's a long time since I've worked for those kinds of places anyway. It just feels very old-fashioned to me, that kind of stuff.
Okay, great. We'll take one last question from Andy Gray. To testing a user interface is traditionally hard. Is there any traction in the assertion that the gaming is different because it is so UI heavy?
I think that is, you know, where the point at which game development challenges, you know, a conventional approach to test-driven development, continuous delivery, that kind of thing. But I think, as I've kind of touched on a few times, but not really nailed, is I think that's a difference in scale rather than the specifics. So if you build a really rich website or a rich mobile phone app or whatever else, that's still got a user interface. Now, the point that's difficult to test in any software system is the point at which that software system touches reality. So whether that's, you know, controlling a hardware device or through the UI or interacting with, you know, through the keyboard or whatever else it is, it's where it touches reality that is hard to test. And that's because you don't have an endpoint. You don't have something where you can easily plug into to evaluate what's going on. So there's a variety of techniques that you can use. You can either kind of externalize somehow. So you could imagine, I'm not proposing this as a real solution, but you can imagine, you know, the game writing to some kind of virtual surface where you could evaluate what it looked like and so on. It sounds kind of crazy, I know. But also, more simply, what you could do is you architect the system so that most of the logic in a game shouldn't be in the pixel painting. It's about the interactions. It's about the AI for the way that the characters interact with each other and objects in the scene and all that stuff. That's all virtual stuff. That's a thing that's happening inside a synthetic world inside of the game. That's a beautiful candidate for being able to write tests against. And so you could evaluate all of that stuff in simulation and then have a thinner layer that just renders the painting of the pixels onto the screen, you know, which is a big deal. Don't get me wrong. There's work to do there, but that's not. That means that the whole bulk of the work, the bulk of testing something like a game and the gameplay and all that sort of stuff, you could test in simulation. I do work with one of my regular clients builds big, complicated scientific instruments, and you know they are moving towards testing these. These are at least as complicated as a game, but they're moving to, you know, test more and more of their stuff in simulation so that they don't have to test it with the real scientific instrument, or at least they limit the degree to which they test it. They can learn lots without the scientific instrument and then learn a little bit at the end when they plug it in. And I'm sure that Tesla do. I am absolutely 100% certain that Tesla do the same kind of thing. You know, you don't have to have the whole car in place in order to be able to test whether the software works. And I see no reason why a game should be different. It's more difficult, but it's just a matter of scale.
Great. We're going to have to draw it to a close there. Thank you very much for everyone's questions. And thanks for there's been great to see so much discussion on the chat panel as well. I hope people find this a useful session. Many thanks to Dave Farley for joining us today and for sharing his insights into software engineering and what we can learn from the Cyberpunk 2077 release. I'll put a link to the YouTube video in the chat panel. Next week, or sorry, in 2 weeks' time, it will be our next Expert Talks Online. And in that session, the Equal Experts tech lead, Adam Hansrod, will be talking about how digital platforms fail. And in this talk, he'll be showing about how a digital platform can help an organization scale their IT delivery. He'll be covering what smooths the path of digital platforms and what are common problems to avoid. So I'll be putting a link in the chat if you'd like to sign up for that. Dave, one last question for you. So when do your talks come out? When do you publish new YouTube videos?
I publish, thank you for asking me. It gives me a chance to do a plug. I publish videos at 7 p.m. on Wednesday. So there is one that's been published 5 minutes ago on 5 ways to improve your code.
Great. Excellent. So head over to Dave's YouTube channel if you'd like to watch that. Okay, have a good evening, folks. Thanks very much for watching. By the way, if you know of people that would like to see this talk again, Dave's going to be doing all over again. Thank you, Dave, in a couple of hours. Which will be 9 p.m. GMT. There's links to sign up to watch Dave do this talk again on our the Expert Talks Online section of our website.
One more thing, I've just posted the link to the small teams research.
Brilliant. Okay, thanks very much. I hope Paul Dambra was online still to get that. We'll make sure that gets to him somehow.
Thank you.
Great. Okay, thanks very much. Have a good evening, folks. Bye.